Thank you so much. Thank you again, Mr. Fendi, for introducing myself. And now I would like to a bit introduce my company, explaining actually why we are here, why we are doing this, want to share our experience on enzymes, and also why and what we can bring for your markets, for your company. Actually, you see on the screen the a bit timeline history of our company development, and you see two logos. One already mentioned by Fendi is the Palital, and other logo, Aveva Biochem, you see also downstairs. Actually, the history of our company was started more than 100 years ago in the Belgium. And those time, the biggest Belgian farmers decided to create a cooperative to promote their production, to grow together faster and become bigger. Later, and those they are created our company. Later on, in 1923, actually last year was 100 years ago, they built and set up first feed factory in the Antwerpen in the Belgium, and so far this is one of the oldest and biggest feed factories in the Europe. So having 100 years already. Of course, it had a few times renovation to be in terms of equipment, to a few times modernization, and still now operate. Later on, in cooperation, company very famous Belgian beer producer, maybe you know and have in your country, Stella Artois. They requested Aveva to do scientific research with the enzymes on the barley. You know, the barley is the main source for beer production. And during this research, Aveva recognized very strong impact of the NSP enzyme on the barley, and so recognized the potential what could we bring with the enzymes used for the feed industry. Actually, a bit later on in 1988, Aveva launched a biochemical lab which was specialized exactly for investigation, research around the enzymes analysis, enzyme analysis, but also was very focused for raw material analysis and to understand better how and what could be applied later for feed production. So then we can tell from 1988 or 1985, for 40 years we already doing the research with the feed materials, with feed production and producing NSP enzymes. So far, later on, the company, of course, growing, becoming bigger, and in 2021, Aveva Biochem was merged with another company, Dutch company called Palital. This is also a company producing the feed additives and having the very strong position on the butyrates production. And these two companies were merged under the name of the Palital. This is why you see on the logo, on the screen, both logo and Mr. Fendi was introduced me as Palital. So far, for this 100 year, looking for who we are the big group of the companies, and we have 14, we are biggest feed producer in the Belgium. We are number 2 feed producer in Netherlands. In total, we have 14 feed mills in the Belgium, Netherlands, Germany, and the France, and producing more than 2 million tons of the feed. This is the feed department. On top of it, we have the feed additives production department. We have research center. We have a lab. and of course research station where we first test and develop new products and implementing to the market. All our products, actually enzymes, what I will tell you today, was first developed on the demand of our feed production, and then it using for today and testing on this side. So over 2 million of the feed every year we are produced with these enzymes, and know how it's in the best way to implement, and they have a big data on its contribution. In my presentation, I will not talk you that much about our product, but will try to focus more on the NSP enzyme. We'll tell the different enzyme types and also why we are using the enzymes, what it could bring, and the positive effect, what you can see on your flock, on your companies, on your animals, and which positive effect you can ensure with the using NSP enzyme. Also, in few words, I will try to tell on different products and NSP enzymes products, what you can meet on the market, and how to choose the proper one, how to identify the one you need for your, exactly for your feed, for your formulation, for your animals. So first of all, I would again summarize. I pretty believe Mr. Tegu already mentioned, but would like to repeat. If we look on all enzymes, what we have on the market, here we can have three, all enzymes we can split on the three groups based on mode of action. First of one is the phytase, used for many years, and the phytase working to destroy, to hydrolyze the phytic acid. The second one is NSPases, what we will talk today mainly, and it's working to hydrolyze the fibers or polysaccharides. And the second one group, based on mode of action, is the proteases, and it's working to hydrolyze big and complex protein molecules. Before to go into NSP fibers and what NSP enzymes, let's make the definition what is fibers, for what it works for. And according to the one of the latest definition for dietary fibers, you can see on your screen is the dietary fibers means carbohydrate polymers which are not hydrolyzed by the endogenous enzymes in the small intestine. By practice, it means the animals, poultry, swine, they don't produce endogenous enzymes which able to hydrolyze the fibers. Actually, this is the main reason why we must to use the NSP enzymes in our formulation. For the fibers, from the left side, you see this is the plant cell scheme or picture, and it has some content inside, and the fibers, they are mainly structural part of the cell wall. You can see here the part of the cell wall, and it has many different chemical polymers cross-linked, and some of them you see hemicellulose, cellulose, pectin here cross-linked all together. So if we look on the plant cell, again, we have digestible cell content. What is inside is the sugars and the starch, and we have less digestible cell wall, which is a few structures is the lignin. One of them, lignin, is the main part, up to 40-50% dry matter of the wood. So we are not using wood for the feed. So we don't have the lignin in our feed, what we are producing in our feed materials. The second part is the cellulose. Cellulose is the structural parts, and this is the main parts in green part of the whole plant. So thanks to the cellulose, the plants are growing, they are becoming longer, and also it's ensure the strength and the form of the plant. But again, we are almost not using the green parts of plant in the feed production. We are mainly use cereals, or we are using the seeds. The other parts of cell walls, we actually can split cellulose, hemicellulose, and pectin. They all so-called NSP, means non-starch polysaccharide. Cellulose, as we already, as I just mentioned, it's almost we almost don't have in the feed. It's very small portion, only in some raw materials, for example, like in the corn. Let's focus more on the other two. It's the hemicellulose and the pectin, what it is. So the hemicellulose is again the group of the polymers, which is the xyloglucans, xylans, manans, galactomanans, and the beta glucanase. If you look for xylans, so the xylans is the beta 1,4 linkage of the xylose, and with the substitution of arabinose, and they have up to 30% of the raw materials what we are using, and especially they are very abundant in the cereals. So to digest, here from the right side, you see the picture, one of the picture xylan molecule, and as mentioned, this is the beta 1,4 linkage of xylose molecules. And of course, to hydrolyze this molecule, we are using 1,4 beta xylanase. So just to work on xylose, to hydrolyze the arabinoxylans. The most part of the xylans, they are insoluble fibers, and they are what we are called, they are creating so-called nutshell effect. From the right side, you see the nut, and it's of course, as most of the nut, it's covering, it has some shell, nutshell, and inside we have the valuable for us edible part of the nut. So first, to eat, we need to break down the nutshell. The same happening with the xylans. If you will see on the microscopic picture here the blue line is the xylans box or xylans shell, and it's insoluble. And inside you see the granules of other nutrients. In the most cases, this is the starch. So considering the xylans insoluble, when it's when the raw materials go into the intestine, it's not soluble, and starch and protein, they will entrapped inside, and they will be carried out to the from the upper part intestine to the hindgut, where is no anymore digestion or absorption of the nutrients. In this way, xylans, they are limiting nutrients absorption, in particular mainly the starch and the protein. They are not allowed to use all raw materials, all nutrients what we are paid when we are producing formulated feed, and also they are limited, creating this kind of box or nutshell. They are limiting the accessibility, I guess, of endogenous enzyme to those starch and the protein. If you are looking for this graph based on the research done by many years in cooperation, our company Aveva with the Gent University, and you see here the yellow bars is the percentage of the protein what linked to the fibers. Means if we are not using the NSP enzymes, the big part of this protein will have very limited absorption and almost will be not used by the animals with its main nutrition for its main nutrition role. And for the corn, you see up to 50% of the protein it's linked for the fiber. This is why so important to use the NSP enzymes, not to digest the protein, but to open this box, open this cage, and make this protein and the starch as well, as we saw on previous slide, available for the endogenous enzymes, for amylase or for proteolytic enzymes what produced by the animals. The second structure of hemicellulose is the beta-glucans, and you see the beta-glucans is the linked glucose molecule. So, and there is several different types of glucans, but what is the one which are mainly we can see and exist in the raw materials, what most important for us is the linear 1,3 and 1,4 beta-glucan links. And you see on the picture, on the graph, you see the glucose molecules linked in the 1,4 or 1,3 position in linear polymer. And of course, if you are using the NSP enzyme on your specification, you can see 1,3 or 1,4 or both 1,3, 1,4 beta-glucanase to be able break down this linkage between the glucose molecules. The third part of the NSP enzyme is the pectin, and the pectin is the substance important also from the primary cell wall, and also it's the polymer of the D-galacturonic acids with the 1,4 linkage galactosidic linkage of D-galacturonic acids. You here on the graph see two D-galacturonic acids which link in the position 1,4 between of them. And if you see on the right picture here, you see in the cell wall the yellow polymers is exactly the pectins one what we consider. Despite on the graph, it's the pectin mentioned seems quite easy, but in reality, the pectins is the very complex and very branched molecule. Here, just the one example. In reality, in reality, there is the millions of variations of pectins there is in the raw materials. Yellow chain, you see this is D-galacturonic acid, and it's very branched, so many different structures can attach and attaching for the D-galacturonic acid. It's the galactose, arabinose, xylose, and many other things attached. Both glucans and the pectins, what we previously considered, they belong to group of NSP which are soluble. So they create so-called gel effect, and it's happening because both of them has a high water binding capacity. So they bind in the water and creating kind of the gel, means in the intestine, in the digestive system, they are increasing the viscosity of digester. And in this way, first, when digester has high viscosity, it's limiting the endogenous enzymes to get in contact with the substrate. The second, nutrients has slowly and not it's reduce the nutrients come to the absorption side in the intestine cell and to be absorbed. Also, one of the big negative effect of glucans and the pectins due to this high water binding capacity, they are reduce the nutrients feed intake. It's happening because the animals have the physical feeling of the fullness. They don't want to eat. They don't feeling hungry, and it seems like when you have a lot of food on the dinner, you going to sleep and you cannot sleep, you are feeling full. The same with the animals. Those feed which has high viscosity, it's giving the animals high physical fullness, and in this case it's very visible. You can easily recognize your animals eat not that much as they should eat. So, and the pectins among these two glucans and the pectins has the extremely high this ability to bind the water and ensuring the high viscosity of your animals. You will know, most probably you will know the cassava cakes. It's very nice, very juicy. We all like it, and this juicy effect happening because the cassava has very high amount of the pectin. So this is why it's keeping the water and giving us this very nice taste, very good juicy effect. But also you see the one more picture, it's the 100% premium fruit pectin super gel. So this is again one of the proof of this high gelling effect what could be ensured by the pectins. But we also use the cassava in the feed, and what is good for food, it means not that good for the feed. And you see, as I mentioned, that from the picture you see, cassava has very high amount of the pectin, but maybe not everyone use the cassava in the feed, or if you are using not big portion and think this is not for you, you have no problem with the pectins, please look on the soybean meal. 100% of the customers, 100% of feed formulations, feed formulas, you have in the soybean meal. And soybean meal has 22% in total of NSP. From this 22%, 7.6 is the pectin. If you will recalculate, multiply, divide 7.6 by 22, you understand, you recognize soybean meal has minimum 35% of the pectin. So you are using the xylanase, you are using glucanase, but you still have high viscosity because of the pectins. And actually the pectins you may find in the most of raw materials. You see cassava, soya, DDGS, lupin, palm kernel meal, rice bran, coconut. So most of all raw materials you are using, they have more or less pectins inside. So again, does it matter for you? Please think, and it's how much how this information, how the pectin could be relevant for you. If we see on those enzymes NSP, what used mainly on the markets typically is the combination of the xylanase and the glucanase. But again, if we look for those raw materials, what used in the feed and the total NSP content, we also will see that all of these raw materials, they have pectins. Even the corn has only from one first look, only 1.1% of the pectin. But if you will multiply by this 8.3, so the corn has 13% of the pectins from total NSP content. And if we multiply by average use of the corn, 50% in your formula, it's the huge amount of the NSP, what we are not taking care, and it's creating this very, very high viscosity in the feed. So if you are using the xylanase and the glucanase combination, you use xylanase to hydrolyze insoluble fibers. You have glucanase to hydrolyze the soluble glucans, but you still have high viscosity because most of the enzymes on the market, you don't have the pectins. So this is matter for you. One of the research trials we did in the past to evaluate the effect of the pectin, if it's create the negative effect for the production or not, or the other question, if the can pectinase ensure some additional effect to xylanase glucanase. We got very nice results. The gray bar is the only combination xylanase and the glucanase, and the blue one, the same xylanase plus glucanase combination plus pectinase. And you can see growth rate plus 6%, FCR minus 5%, feed intake plus 4%. You remember when I talk about the gel effect, about the high viscosity, one of the first visible negative effect is the reduce the feed intakes. When we use the pectinase, here the very, very clear effect, we reduce viscosity, animals eat more feed, and of course we have a better growth rate and the higher efficacy of feed used by animals. First, because the animals eating more. The second, more and less viscosity and higher nutrients absorption and higher efficacy of endogenous enzymes what animals produce. This is one of the best proof of importance pectinase and to do the use. When we, for these 40 years, as I mentioned already, 40 years ago, we created the lab which was dedicated to do the raw materials analysis and, of course, research for enzymes. And during these 40 years, we did a lot of feed ingredients. We analyzed a lot of feed ingredients for different fibers, what it has. And here you see some of them. And the blue part is the xylans. Yellow part is the glucans, and the green part is the pectins. The brown one, the all other altogether. So as you see, in most raw materials, very, very, very minor part of other fibers. Only 3 types of the fibers for 98% of the feed. Xylanase, xylans, glucans, and the pectins. The exception only coconut and palm kernel meal, where is the big portion, brown portion of others. Mainly this is the manans. The other don't have manans almost or traces, and the manans only the case for 2 raw materials you may have. So if you don't use coconut copra meal or palm kernel meal, you don't need to take care about the monones. Only three enzymes is the xylans, glucans, and the pectins you have think about. In general, for these 40 years, we did analyze more than 50 raw materials, and we have complete database, which enzymes, which fibers they have, and as a conclusion was only three main types have all raw materials. Anyone which you will take, there is the only three main raw materials. So finally, doesn't matter which type of the feed you are using. This is the corn soya based diet or wheat soy based diet with some alternative ingredients or not. They all have xylans, pectins, and the glucans. Some of raw material has less pectins, some has more, some has less xylans, and the other one has more xylans. But only three raw materials. Means if you are thinking about the enzymes, please pay attention and consider three enzymes what you are needed to hydrolyze insoluble xylans and hydrolyze soluble pectins and glucans to reduce viscosity of your feed and improve also gut health of your animals. This is xylanase, glucanase, and the pectinase. The second issue on the market, what you most probably already met and considering how to compare the products. If you will take two labels or two specification of your of different products from the market, you will you easily can recognize. For example, one has 40,000 units of xylanase, another has only 1,000 units xylanase. What does it mean? Means the one product more diluted and another one concentrated, or something else. Actually, here on the screen, you see the description of the seven different units, actually the seven different methods. And you can see, and all of them only for xylanase. And if you will see, the first method is used as a substrate, used oat spelt at pH 5 and 50 degree. Another use wheat arabinoxylans with the pH 3.5 and 40. Some use backwood xylans with the pH 6 and 70 degree. So you understand it's impossible to compare at the end absolutely different units. So, and by the practice, it means it's impossible to tell which products more concentrated, those one which has on the label 40,000 units of xylanase, or those which has on the label only 1,000 or 2,000 units of xylanase, because the units are different. So this is actually what I wanted to show you. Hope now you have more understanding what is the NSP enzymes, why we are used, and which fibers with which enzymes we can hydrolyze. And again, I thank you for your time, attention, and hope you have questions what I will try to answer. Thank you so much.
Oke, baik. Saya akan meresum sedikit poin-poin yang ada pada presentasi dari Mr. Roman. Yang pertama itu adalah bagaimana Mr. Roman menekankan pentingnya penggunaan enzim NSP atau non-starch polysaccharide pada penggunaan bahan baku fiber atau serat, ya. Karena bahan baku fiber atau serat ini bersifat insoluble, ya. Tadi dijelaskan juga ada nutshell effect, ya, bagaimana nutrien itu terjebak dalam dinding sel bahan baku tersebut, sehingga dibutuhkan enzim untuk membuka dinding-dinding tersebut, ya. Dan jika kita berbicara mengenai NSP, ini memang penting untuk melihat hemiselulase dan kadar pektin juga, ya. Nah, pektin ini adalah salah satu lapisan yang memang jarang diperhitungkan oleh nutrisionis ya. Faktanya melalui beberapa penelitian yang dilakukan oleh baik itu oleh Palital maupun dari university, memang pektin ini adalah salah satu bagian dari fiber yang memang lumayan memiliki persentase, sehingga perlu kita hidrolisa agar dapat terserap dalam tubuh. Nah, dan perlu dicermati juga bahwa pada unggas dan babi ini mereka tidak menghasilkan enzim endogen untuk menghidrolisis pektin dalam pakan, sehingga dibutuhkan enzim pektinase dari luar yang dicampurkan lewat pakan. Ya, beberapa contoh tadi dijelaskan, khususnya seperti jagung, DDJS, SBM, bahkan kasava, ya, singkong itu sangat penting untuk penggunaan dari pektinase tersebut, ya. Dan ketika kita melihat total NSP, ya, jadi kalau kita sebagai nutrisionis kita melihat total NSP, kita jangan hanya melihat total NSP-nya saja, atau kita juga perlu melihat secara lebih detail lagi, yaitu arabinoksilan, glukan, pektin, dan bahkan tadi mananasenya, ya. Karena beberapa kejadian itu pektin itu tidak bisa dihidrolisa oleh hanya silanase dan glukanase saja, gitu. Nah, beberapa hasil penelitian, beberapa manfaat dari penggunaan pektinase ini adalah untuk meningkatkan growth rate, ya, menurunkan FCR, dan juga peningkatan feed intake akibat dari penurunan dari viskositas tadi, ya, karena memang pektin ini dia memiliki sifat gel effect tadi yang menyerap air, ya. Nah, kemudian dalam pemilihan enzim ini tadi menyambung presentasi dari Pak Teguh, dijelaskan bahwa penting untuk melihat teknologinya, ya. Nah, produk yang dimiliki oleh Palital ini, yaitu AVX, itu dia concern terhadap enzim activity dan juga heat stability-nya. Bahkan diklaim di sini AVMix PGX ini dia bisa tahan sampai dengan 90 derajat Celcius. Nah, kenapa mereka bisa concern dan memiliki banyak database terhadap enzim activity dan juga total NSP, ya, dari bahan baku, karena memang perusahaan mereka itu lebih dari 100 tahun itu sudah bergerak di bidang feed, ya. Bahkan dia untuk unit produksi enzimnya sudah lebih dari 40 tahun mereka berada di sana. Dan grup dari Palital ini, yaitu Harvesta Group, itu adalah perusahaan atau perusahaan feed mill terbesar di Eropa, ya. Mereka memiliki 14 feed mill dengan total produksi 2 juta ton per tahun. Nah, kemudian di pasaran ini kita kalau melihat produk enzim itu terbagi menjadi 2 jenis. Ada enzim jenis koktail dan blend. Tadi dijelaskan bahwa koktail itu adalah diproduksi oleh satu bioreaktor yang sama, sehingga dia menghasilkan beberapa enzim dalam satu kali produksi. Sedangkan blend, di mana produk AVMix PGX ini adalah jenis yang blend, itu adalah gabungan dari beberapa bioreaktor yang memproduksi fokus terhadap enzim-enzim tertentu. Ya, jadi kalau dia isinya pektinase, glukanase, sama silanase, mereka memiliki 3 bioreaktor berbeda. Ya. Dan untuk membandingkan produk enzim di lapangan, tadi juga dijelaskan, tidak hanya bisa melihat dari banyaknya jumlah enzim yang banyaknya jumlah jenis enzim yang terdapat pada label, tapi bagaimana fungsi dari enzim-enzim tersebut beserta dengan enzim activity-nya, gitu. Jangan-jangan banyak jenis enzim dalam kontennya, tapi enzim activity-nya tidak mencapai standar atau kriteria untuk membuka tadi, ya, serat-serat pada bahan baku.